Welcome to this new section of our content, the frequently asked questions. Trust me, these are real questions from real people like you trying to be successful in software. And this one came up recently in a session with my friend Ricardo. And he was anxious because he's a senior software engineer. But now, with all this AI, what should he study next? What should be the next investment of his precious time? So that's what I'd like to talk about today. We're going to talk about what to study next, why in the first place should we study instead of just asking AI and invest time in learning stuff. Then I'm going to give my perspective on how to approach learning and how to approach this investment of your time. And finally, some things you might enjoy learning. So let's do it. First of all, the goal for most people is to get and hold a job or to take the next step in their current position. So, for that, you need to know things, right? You can't just ask AI for everything. For example, here in my suggestions on LinkedIn, I have a lot of stuff around Kubernetes, for example. So that's a focus for me. But for other people, for you, you will have different suggestions, different context, but it is the first place that I recommend people to take a look. What is in the job description of the job you want, of your next step? So here, for example, I'm taking a look at this NVIDIA position, and it says that I should learn about Kubernetes, about GPUs, about uh, the NVIDIA software stack, so NeMo and things like that. And of course, Go and Python, right? And cloud providers. So those are the things I would learn for in the context of getting this position. And even with AI, those positions are still there, still a lot to learn. And even if you like AI, you can search for AI opportunities. And it's a relation of building and using AI. But in all of them, you're going to find things that you should learn. And another reason is because I like it. I think a lot of people enjoy the game even if it's not winning, for example. In chess, a game that's been ridden with AI and mostly solved by computers this day, at least better than most humans can. But people still enjoy playing it and not cheating at it. So people learn it. And I think computing and software and skills, even music, have this perspective. Even if AI can do it, doesn't take my enjoyment of learning and doing it as well. However, I think it's always important to focus either on the opportunity at hand or the ticket. So I'm a very strong advocate in ticket oriented learning, and you don't need to go and study, become a doctor in a field before you get a job, before you do a project, before you get a ticket. I think it's much more effective to do the other way around. Go for the tickets, take one, take two, take three, take hundreds of tickets, and after that, you'll have the experience and be an expert. And then you can go ahead and, if you want, of course, go do your doctorate. But I think the important thing is not to be anxious and suffer about the amount of things that are to learn. So, for example, in this Quarkus project that I follow closely, if you take a look at the ticket queue, there's reactive message, OpenShift Kubernetes clients, memory for Hibernate, a lot of stuff that is impossible for someone to be single-handedly taking this. So if I focus on a single ticket, for example, this OpenShift client, a native integration, then I'm going to learn OpenShift. Then I'm going to take a look at this. Then I'm going to invest a little bit, enough to close this ticket. And after you get this ticket done, move on to the next. If you don't have a ticket or a project yet, there is a very popular repo on GitHub called Project Based Learning under Practice Tutorials. And here you're going to find many projects in different programming stacks, each with its own context. So I highly recommend taking a look. If you like building games, there's games. If you like doing enterprise apps and web, there is that as well. Also, you are most welcome to join our org and our projects. So under ProdBytes, we have Pet Hub, Insurance Hub, and some demo apps to do this kind of demonstrations, help people, show a bit of the technology, and grow together. So let's do that if you'd like. And of course, you can start your own project, start your own organization on GitHub, and go ahead. If that's your path, and very often that's the case for my colleagues, I recommend starting just like Amazon does with this backward process. So start with the launch document, start with this one page or a couple pages long, not big documents, but this is a press release. So here's the archive of Amazon press releases is available. This is one from 2006 announcing Amazon Web Services being launched along with S3. So it tells what S3 is, the object storage service we all use and love. This is for write and reading objects and making them published on the web, and being scalable and fast and reliable and inexpensive and so on and so forth. So if you write up what you want to launch before you build, that can be really helpful. And this gives you also some time perspective. So I'd say in 6 months, for example, I want to launch this project, this product, and this give you some scope. And also, one recommendation I would do is not to start with the tech stack, the language in particular. Start with the business, the concepts, the things that you want to launch and when you want to launch them. And after that, take a look at the libraries and frameworks. So very often, the libraries and frameworks will determine the language. So a lot of people compare languages and advocate for languages on social media, and you see a lot of these discussions, and they are mostly useless because you often can't do anything about it. For example, if you're using Apache Spark for your data projects, for example, that will define the languages. So here Spark has a Python interface, supports SQL, there's a Scala interface and a Java interface as well. So those are the ways you can do Spark, or even R if you're into R-Lang. But it's probably not going to be a good idea to do C or C++ for a Spark project. It's sometimes possible, but those are the recommended programming languages and interfaces for Apache Spark. And again, every domain will have its library and frameworks, and once they are chosen, the language is just the currents. And when you have your project and your tech stack set, then you start building these things. And very often they're going to be on the web, and you don't necessarily need to learn a lot to build those things. For example, there is a lot you can build on no-code and low-code tools. I really like Squarespace, so our new1.com website is on Squarespace. And here you can see that there's very little coding. I can edit all the sections of the website without using a single line of code. However, if I want, I can go here to custom code and code injection and add the bits of code that I want. But you can see that this is a bit limited, right? Not the way you would build a full app, but it's one way to start. Also, there's these low-code services and projects like AWS Blocks and others like Anti-Gravity and many others now with AI Build 44, things like this. But these Amazon examples are nice. I like to use Amazon Web Services. I talk a lot about their stuff here. So Blocks is the new low-code service to build apps with databases, authentication, real-time, asynchronous jobs, and without having to code all those things yourself. And also, if you want to take the next step, you may do it without even needing a full programming environment. There are static website generators like Hugo that can build incredibly fancy websites like IMDb, blogs, everything that's around content more than the interfacing is a great target for websites. So if it's not a game or an enterprise app, if it's around your content, your blog, or something knowledge specific, like a collection of movies, like IMDb or something like that. Static websites are very simple and easy to build because they will generate the pages and the code for you, and you can serve that directly and not having to code a lot. And those are very efficient because you don't need even a computer, a server to host them. You can just serve the files directly. However, if you are doing enterprise apps and games and things that are real web apps, you can, of course, go to your favorite web framework. In our case, in ProdByte apps, some of them use, again, the most specific and adapted framework for their solutions, but I've been using a lot Svelte and SvelteKit. I've did React, Angular, Vue.js, all of that before, but SvelteKit and another one called Vaadin are very often in my tools of choice. I know they're not the most popular, but that's another choice. I don't need to use the most popular stuff out there. I'm not hiring a lot, so that's okay. If you are needing to hire a lot, maybe it's a good idea to use React or Vue.js or something that's more widely used. But SvelteKit is getting a lot of traction and popularity and way more pleasant to work. And I really like this feature that it has adapters that you can use to do a serverless or static generation, so it covers all those styles with the same framework, which is nice. And of course, if you're not doing web, if you're going for a game, for example, that needs optimal performance, or devices where you need to integrate with the camera and the sensors and all that mobile devices have to offer these days, or even your native desktop, then we would go to a full-blown app framework like Flutter or something like that, where you would have all the power and sensors and everything on the device at your service. So that's the way I think about web apps. I start from as low code as possible and go up in complexity as we go. Always focused on the business proposition, the thing that we're trying to launch, and as soon as possible broken down in individual tickets. So we just learn enough to close the ticket or to prepare for the opportunity hand. And that's what I think it's important to learn next and how to go about it. See you in the next one.